Welcome to Multiple Spanning Tree Protocol. IST, CIST, and CST, unlike PVST+ and Rapid PVST+, in which all the spanning tree instances are independent, the MSTP establishes and maintains two types of spanning trees. An internal spanning tree, IST, which is the spanning tree that runs in an MST region. Within each MST region, the MSTP maintains multiple spanning tree instances. Instance 0 is a special instance for a region, known as the internal spanning tree, IST. All other MST instances are numbered from 1 to 4094. The IST is the only spanning tree instance that sends and receives BPDUs. All of the other spanning tree instance information is contained in M records, which are encapsulated within MSTP BPDUs. Because the MSTP BPDU carries information for all instances, the number of BPDUs that need to be processed to support multiple spanning tree instances is significantly reduced. All MST instances within the same region share the same protocol timers, but each MST instance has its own topology parameters, such as root device ID, root path cost, and so forth. By default, all VLANs are assigned to the IST. An MST instance is local to the region. For example, MST instance 1 in region A is independent of MST instance 1 in region B, even if regions A and B are interconnected. A common and internal spanning tree, CIST, which is a collection of the ISTs in each MST region, and the common spanning tree, CST, that interconnects the MST regions and single spanning trees. The spanning tree computed in a region appears as a subtree in the CST that encompasses the entire switch domain. The CI street is formed by the spanning tree algorithm running among switches that support the 802.1W, 802.1S, and 802.1D standards. The CI street inside an MST region is the same as the CST outside a region. Operations within an MST region. The IST connects all the MSTP switches in a region. When the IST converges, the root of the IST becomes the CIST regional root, called the IST master before the implementation of the 802.1S standard. It is the device within the region with the lowest device ID and path cost to the CIST root. The CIST regional root is also the CIST root if there is only one region in the network. If the CIST root is outside the region, one of the MSTP switches at the boundary of the region is selected as the CIST regional root. When an MSTP device initializes, it sends BPDUs claiming itself as the root of the CIST and the CIST regional root, with both of the path costs to the CIST root and to the CIST regional root set to 0. The device also initializes all of its MST instances and claims to be the root for all of them. If the device receives superior MST root information, lower device ID, lower path cost, and so forth, than currently stored for the port, it relinquishes its claim as the CIST regional root. During initialization, a region might have many subregions, each with its own CIST regional root. As switches receive superior IST information, they leave their old subregions and join the new subregion that contains the true CIST regional root. All subregions shrink except for the one that contains the true CIST regional root. For correct operation, all switches in the MST region must agree on the same CIST regional root. Therefore, any two switches in the region only synchronize their port roles for an MST instance if they converge to a common CIST regional root. Operations between MST regions. If there are multiple regions or legacy 802.1D devices within the network, MSTP establishes and maintains the CST, which includes all MST regions and all legacy STP devices in the network. The MST instance is combined with the IST at the boundary of the region to become the CST. The IST connects all the MSTP devices in the region and appears as a subtree in the CIST that encompasses the entire switch domain. The root of the subtree is the CIST regional root. The MST region appears as a virtual device to adjacent STP devices and MST regions. Only the CST instance sends and receives BPDUs, and MST instances add their spanning tree information into the BPDUs to interact with neighboring devices and compute the final spanning tree topology. Because of this, the spanning tree parameters related to BPDU transmission, for example, hello time, forward time, max age, and max hops, are configured only on the CST instance but affect all MST instances. Parameters related to the spanning tree topology, for example, device priority, port VLAN cost, and port VLAN priority, can be configured on both the CST instance and the MST instance. MSTP devices use version 3 RSTP BPDUs or 802.1d STP BPDUs to communicate with legacy 802.1d devices. MSTP devices use MSTP BPDUs to communicate with MSTP devices. 802.1s terminology. Some MST naming conventions used in Cisco's pre-standard implementation have been changed to identify some internal or regional parameters. These parameters are significant only within an MST region, as opposed to external parameters that are relevant to the whole network. Because the CIST is the only spanning tree instance that spans the whole network, only the CIST parameters require the external rather than the internal or regional qualifiers. The CIST root is the root device for the unique instance that spans the whole network. The CIST external root path cost is the cost to the CIST root. This cost is left unchanged within an MST region. Remember that an MST region looks like a single device for the CIST. The CIST external root path cost is the root path cost calculated between these virtual devices and devices that do not belong to any region. The CIST regional root was called the IST master in the pre-standard implementation. If the CIST root is in the region, the CIST regional root is the CIST root. Otherwise, the CIST regional root is the closest device to the CIST root in the region. The CIST regional root acts as a root device for the IST. The CIST internal root path cost is the cost to the CIST regional root in a region. This cost is only relevant to the IST, instance 0. Hop count. The IST and MST instances do not use the message age and maximum age information in the configuration BPDU to compute the spanning tree topology. Instead, they use the path cost to the root and a hop count mechanism similar to the IP time to live TTL mechanism. By using the spanning tree MST max hops command, you can configure the maximum hops inside the region and apply it to the IST and all MST instances in that region. The hop count achieves the same result as the message age information, triggers a reconfiguration. The root device of the instance always sends a BPDU, or M record, with a cost of 0 and the hop count set to the maximum value. When a device receives this BPDU, it decrements the received remaining hop count by 1 and propagates this value as the remaining hop count in the BPDUs it generates. When the count reaches 0, the device discards the BPDU and ages the information held for the port. The message age and maximum age information in the RSTP portion of the BPDU remain the same throughout the region, and the same values are propagated by the region-designated ports at the boundary. Rapid convergence. The RSTP provides for rapid recovery of connectivity following the failure of a device port, or a LAN. It provides rapid convergence for edge ports, new root ports, and ports connected through point-to-point links as follows. Edge ports. If you configure a port as an edge port on an RSTP device by using the spanning tree port fast interface configuration command, the edge port immediately transitions to the forwarding state. An edge port is the same as a port fast enabled port, and you should enable it only on ports that connect to a single end station. Root ports. If the RSTP selects a new root port, it blocks the old root port and immediately transitions the new root port to the forwarding state. Point-to-point links. If you connect a port to another port through a point-to-point link and the local port becomes a designated port, it negotiates a rapid transition with the other port by using the proposal agreement handshake to ensure a loop-free topology. Proposal and agreement handshaking for rapid convergence. Device A is connected to device B through a point-to-point link, and all of the ports are in the blocking state. Assume that the priority of device A is a smaller numerical value than the priority of device B. Device A sends a proposal message, a configuration BPDU with the proposal flag set, to device B, proposing itself as the designated device. After receiving the proposal message, device B selects as its new root port the port from which the proposal message was received, forces all non-edge ports to the blocking state, and sends an agreement message, a BPDU with the agreement flag set, through its new root port. After receiving device B's agreement message, device A also immediately transitions its designated port to the forwarding state. No loops in the network are formed because device B blocked all of its non-edge ports and because there is a point-to-point link between devices A and B. When device C is connected to device B, a similar set of handshaking messages are exchanged. Device C selects the port connected to device B as its root port, and both ends immediately transition to the forwarding state. With each iteration of this handshaking process, one more device joins the active topology. As the network converges, this proposal agreement handshaking progresses from the root toward the leaves of the spanning tree. In a device stack, the cross-stack rapid transition (CSRT) feature ensures that a stack member receives acknowledgments from all stack members during the proposal agreement handshaking before moving the port to the forwarding state. CSRT is automatically enabled when the device is in MST mode. The device learns the link type from the port duplex mode. A full duplex port is considered to have a point-to-point connection. A half duplex port is considered to have a shared connection. You can override the default setting that is controlled by the duplex setting by using the spanning tree link type interface configuration command.